Okay, this is 4.7b of geometry. We're going to skip their first proof. If you want to go look through it, you may. But we're going to start with our own. So the very first thing, I need to write my given out. So PS is congruent to RS, and that's already marked. And angle PSQ is congruent to angle RSQ, and that's also already marked. So we got a lot of triangles going on here. If I look at what I'm trying to prove, I'm trying to prove that QPT, that guy right there, is congruent to QRT. Before I jump to those little triangles, though, I'm going to prove that these big triangles are congruent. So the first thing I'm going to do is I'm going to say that QS is congruent to QS. Oops. And that's by reflexive. Oh, sorry, given. Okay, so I'll mark that on there. Now I can say that those two big triangles are congruent by SAS. So triangle QPS is congruent to triangle QRS by SAS. Okay, so now I can use CPCTC to say that some other parts are congruent. Well, let's look again at our little triangles up there that eventually I need to prove are congruent. I need to use one of my triangle congruents, so SSS, SAS, ASA, AAS. I won't be able to use HL since I don't have a right triangle. But do you see that these sides are part of the big triangle? So I can say that QP is congruent to QR by CPCTC. Because they're part of the big triangle, right? They were a side along this big triangle. But also, I could use that to prove that those two yellow triangles are congruent. I can also look at these angles. Those are part of the big triangle, right? But they're also part of my little triangle. So I can say QPT, angle QPT is congruent to angle, PQT. PQT, there we go, is congruent to angle RQT. It's supposed to be an R. And that's also by CPCTC. Now if I just focus on that yellow triangle, I can say that QT is congruent to QT. By reflexive. And now I can say that those two little triangles are congruent by SAS. So now I can say my proof statement, triangle QPT is congruent to triangle QRT by SAS. So I started with my big triangles, right? Let's just run through it here. That's S. I'm just separating them a little bit. It was already marked that those angles and those sides were congruent. And I said, well, they both have QS, so these are also congruent. So I said, okay, these are congruent triangles by SAS. And CPCTC allows me to say that their parts are congruent. So I said that QR was congruent to QP. And I said that this angle here, RQS, was congruent to PQS. And then I looked at those little triangles. Right? So this is QRT and QPT. And I said, hey, well, that's the same thing over here. And PQS is the same thing as PQT. That's the same angle. So I marked that. And I said, hey, they both have QT. So I marked those because they're reflexive. And now I had those little triangles congruent. So I looked at the big triangles, got some parts I needed, and then looked at the little triangles. Again, here's another proof if you want to walk through it. We're going to walk through our own here. So first thing I do is I write the given. So angle CAD is congruent to angle EAD. And angle C is congruent to angle E. Okay, so they didn't mark this on the triangle yet, so I'll mark it. So CAD is congruent to EAD. And angle C is congruent to angle E. Okay, so looking at these big triangles, and I'll try to draw them out here. Okay, not quite to scale, but I've already got those angles and those angles. They both have AD, so I can say that AD is congruent to AD by reflexive. Oh, that was given. This is reflexive. So I'll also mark it on my picture up top, but now I have that these triangles are congruent by AAS. So I can say triangle CAD is congruent to triangle EAD by AAS. Okay. Now I am trying to get that BD, here I'll mark it on the picture, BD is congruent to FD. So do you see how that's talking about these little triangles down here? So I need to use what I just proved to get some parts that are going to help me. So do you see how CD is part of the triangle here and it's part of this triangle? So I'm going to try going that route. So I can say that CD is congruent to ED. By CPCTC. And I'll mark that on here. And on my original picture. And now is when I'm going to switch to those little triangles. Oh, whoops, I should move that D. Okay, and I'll mark what I already know. So I already know that these angles are congruent. And I've got that these sides are congruent. Then, this forms an X, so I can use vertical angles to say that these angles are congruent. So angle BDC is congruent to angle FDE by vertical angles. Now I can say that the two triangles are congruent by ASA. So triangle BDC is congruent to triangle FDE by ASA. And now I can say what I'm trying to prove, that BD is congruent to FD by CPCTC. So it's a pretty long proof, right? There's quite a few steps in there. But first try to prove the big triangles are congruent, and then use CPCTC to get that those little triangles are congruent. To get the parts that you need to say those little triangles are congruent. And there's your homework.